The next speaker is Professor Shashidhar, University of Agricultural Science, Bangalore. He's going to talk about success stories in rice breeding for drought tolerance in India. His group has been working on this for the last 20 years. Some interesting stories have emerged. So, Professor Shashidhar.
It's a pleasure. It's on? Yeah. It's a pleasure being here talking to this great audience. I speak of success. That itself is a great feeling because we deal with a trait which is a trait like drought resistance and success. It's a good combination. I'll be telling a few stories today. I'm a storyteller, and these stories are contributed from by many of these people across the country and across the world, of course. We have Satish Verulkar from IGKB, Raipur, Chandrababu, TNA, Coimbatore, and Arvind Kumar, Venuprasad, Amelia, from Erie. Anita Raman is a statistician, Adam Price, Catherine Steele from UK. And the last four names have been the mentors. They have had the patience to teach us, guide us through, and see that we go where they expect us to go. And I think they would be happy to see us at this point in the journey. Drought is said to be a complex trait and difficult to handle, but these two does not bother breeders and deter them from their work, as indicated by the success stories. Complexity has never bothered a breeder because semi-dwarf varieties were developed 20 years or more before SD1 was discovered, or the genetics of SD1 was discovered very recently. And the molecular basis of SD1, 20 oxidase, was discovered even more recently. So, but semi-dwarf was developed, released, revolution made. So genetics, not knowing genetics is not a disadvantage. Like in grain yield and heterosis, still we are working on genetics. And germplasm banks, fortunately, offer a wide range of variability, huge quantum of variability. So we don't have to look outside of the species. We just go to the bank, unlock it, and we have whatever we want as traits. And fortunately, screening, selection, testing protocols are there. We can borrow from the well-watered conditions. So nothing had to be reinvented. Everything was perfect, just to go and achieve. And knowledge was there from textbooks to borrow. You know these famous triangles. I won't have to explain these. These are the famous triangles from textbooks for soil and for pathology. Can we have one for drought? Drought has only three components at the plant level. One is an intelligent root system, where a lot of thinking happens, and effective and efficient roots that do the job they're supposed to be doing. And then this results in a good shoot, well-endowed shoot system, well-nourished with water and nutrients, and that results in grain yield. If a breeder thinks logically, these three steps, and empowers a plant to have these, that's all we need. There are small selection tricks that we did as a collective. I'll tell you how we succeeded. Well, drought deals with water. There's an increasing quantity of water or lack of it everywhere. It's not uniformly distributed. And usually yield is related to water. More water, more yield. That's usual scenario. But in drought resistance, it is reverse. We expect more yield from relatively less water. So there's a contradiction now. So strategies, tools, techniques that apply for well-watered conditions need not directly apply to drought because of this small contradiction that is expected. Well, there's one more thing. If you go to germplasm banks and see the quality of the grains and the high-yielding variety quality, grain quality, the traditional grain qualities are extremely good, nutritious, tasty. Taste is something but very difficult to comprehend. It's individual based, but they're tasty. Many people prefer traditional varieties compared to improved varieties. That's one aspect of the story. Now, for anything to happen in a plant, you need some time, duration, 50 days, 80 days, 120 days. So there's a time frame. There's a small window of opportunity for a farmer to cultivate a crop, and not beyond that or not before that can he harvest. And then biomass is an indication of harvest, that's yield that's going to come. If there's no biomass, there's no yield. So putting all this together, we can see the size of this cube is the size of the pie that a farmer can enjoy, community can enjoy, because all components are here. So we have to somehow make this pie larger. Well, um, a small group of us, Amelia and all of us joined together and published a methodology of fruits. This is a freely downloadable booklet, manual, where we describe, there is an international list of authors, contributors from across the world, across crops, how to study roots. We have done it here and it's downloadable. Now, at Bangalore, this is how we do roots. We have PVC tubes, and this is magnitude of variability that we can see. And this is just like the Vincent Vade's system in ICRISAT, and it's not so sophisticated. It's a SAU, State Agriculture University, but we do what has to be done. Then if there was a Guinness Book of Records for good roots, I would have got it. But unfortunately, there's no Guinness Book prize for a longest root. The longest root that was discovered is 182 centimeters, long time ago. This is what gave me the idea. Why don't we go and explore roots? So when I cross two varieties, that's say Azucena and IR64 or Moro and IR20, this is the magnitude of variability that you get. It is possible to select for segregations just like shoot. Roots behave just like shoot if we could follow it among segregants. That's what we did. We followed roots just like people follow shoots among segregants. It was a tricky thing, but we did it. And this is an example of maize, that corn roots at maturity. The length of roots is 2.5 meters in inbreds. At the end, you can see hybrids. Maybe you can't see it there. And that's the tubes that we use, filled with soil, so real soil, compacted appropriately. So a huge amount of variability that needs to be explored, that can be used. Now coming to success story, that was just a laying the foundation. These are the success stories that are on the platter. This many people have succeeded in this many institutes. US Bangalore is, that's our institute, IGKV Raipur, TNAU, IRI, series of lines starting with 7.3 and 7.4 have made an impact. And the Birsa Agriculture University, I'll go one by one. Proportionately, I'll spend enough time where the complexity is more. Well, the first success story is QTL pyramiding work. You must have seen this paper. Steele et al. Steele works in University of Bangor. Adam Price is amongst us. And John Whitcomb is from BBSRC. He was the participatory plant breeding proponent. Then this was the state of the knowledge at that time. It was not very mature, but we had to rely on this. These are the QTLs, and we had to rely on that. And this is the strategy that we adopted. And this is what we got. These are the pyramided lines, and you see the root system between 2000, 2001, and those years. And this is the variety developed and released. This is Birsa Vikastan 111. Kripko was an NGO which did the job, and we had Birsa University, US Bangalore. I did the root work. Birsa did the phenotyping work, participatory plant breeding, and the UK did the, Bangor did the genotyping work. So it is a well-knit program, and we succeeded. Now coming to my work at Bangalore, and when I studied literature, it was so confusing, but somehow it struck me that only 3 of these are useful directly. One is deep roots, biomass, grain yield in the same order. And one of the costliest equipment I used was a panioperimeter in the farmer's field. I computed irrigated water by cumulative panioperimeter and irrigated fields. I budgeted water for every segregant in the F4 generation. or onwards. That way, I could quantify how much yield was there in each segregant under well-watered conditions and under stress as they progressed. And one tiller from each of these from well-watered would go to my pipes for root studies in retrospect. So both were done simultaneously. And I questioned every method of cultivation. I said, why not direct seed rice? Why transplant? Why puddle? Why level? So none of these were done. This I didn't invent this aerobic rice. This was floating in literature. IRRI was proposing it, and China is far ahead of us in this line. So I just brought it here, and we developed varieties. This is how a crop looks, healthy, and this is how a soil looks. At the soil level, there is no need for leveling, no puddling, and none of these things are required. And this is the yield data that come out the first year of the trial. IRRI coordinated trials, everything statistical analysis done by IRRI, and ARB6, the lines that I nominated are ARB6 and ARB8 and ARB series. You can see the difference, performance. Highest 1969 and 2089 for the highest one, but there is a difference in maturity, days to flowering. You can see that. And this was published by the group at different fora, and the figures are coming up here, and you can see the tables. You can see the performance. ARB series, there one here, all of them higher than the checks, higher 64 and the others. Then we did not look at only the plant, we looked at the soil also. And soil characteristics influence the variety or the performance of the crop. And silicon is one nutrient that does miracles in rice. Rice is a silicon guzzler. It loves silicon. So we tried spraying silicon, and this is what we got. Silicon and nitrogen interactions. And I'll show you the yield figures. You can see 2 tons silicon per hectare with 100 nitrogen. You can go up to 7 tons of yield. So yield, one of the questions that everybody asks me every time is yield related to water? Or you take away water, is yield reduced? No, yield is not related to the quantity of the water you supply to the crop, but the quality of the soil, the health of the soil, and the time spent by the crop. And this is how ARB6 look in a healthy field managed by us. Absolutely no sterility, no spikelet fertility problems and all that. This is in the farmers' fields in Chhattisgarh. Chhattisgarh is our hotspot, IGKV Raipur. And this is another publication from in 2010. These are the locations. What you can see here are the locations across the country, again managed by the trials, three years, and the results are here. ARB8, most drought tolerant. Severe stress, it is given 1.9 compared to others you can see. These lines are contributed by all breeders in the country and across the country, world of course. And IRRI wrote a project on this line and sent a student to ICRISAT with Vincent Vade's system. He quantified the extent of water uptake, and these are the parents of my ARB6, Buddha and IR64. And you can see the water uptake in this is higher, grams per day. So deep root works. And you can see the yield figures now. This is another publication from an international group and national group team, and you can see the yield figures. You can see here, first column is yield, and second and third column are stability parameters. I believe that unstable genotypes are more important for drought tolerance than stable genotypes because our climate is unstable. The weather parameters are unstable. How can you have a stable answer for unstable situation? I believe so, but many people differ from me. This paper differed from me, but that's okay. But the data he is here to see, it's the most unstable genotype maybe, but it is highest yield. Another tables from this, sorry, here the stability ranking. And this is the mean ranking, highest mean ranking, but less stable. But that's fine for me. I breed for drought resistance, not for world border conditions. Now, this is one statement from the last part of this paper. The best performance were ARB8 and ARB6. These lines are good restorers in hybrids also. I grew from TNAU, and watch it, I'm not author in any of these papers, My material is there out for everybody to study, and results are out. And here, these are good restorers. These are the restorer lines and aerobic lines. ARB lines are here. And see the SCA and the GCA, they are pretty good combiners. So it is possible to develop hybrid aerobic drought-resistant rice varieties. It's there in the public domain now. Private sector is interested in hybrids, and they can pick it up. Now, there's something interesting happening in drought and um, grain quality. You know, literature of fruits where deficit irrigation is enforced purposely to increase the quality of the fruits. And it's a strategy to make tastier fruits, more TSS, longer keeping quality. In literature, it's there. But what we observed was our lines were more biofortified. If you see iron and zinc across years, it's not 1 year, it's a DBT funded project. From 2010 to 2016, we have done analysis at several locations, machine replicates using XRF, and these values are what here to see. You can see, watch this line, 36 ppm zinc, I think this is zinc, yeah, zinc, and then iron. If you take away water from the field, the grain gets more nutritious. Up to a certain extent, of course. This extending the strategy of deficit irrigation to rice. Now, fortunately or unfortunately, sometimes you get lucky. I got lucky. The aerobic drought-resistant biofortified lines that I noticed turned out to be aromatic, basmati kind of aroma, under Bangalore conditions. This is unheard of. Not unheard of in improved varieties. Traditional accessions have it. Many traditional accessions are there, which are very prized, but low yielders. Now we have an aromatic line, drought tolerant, biofortified, and aromatic. And there's some little bit of extra oil also, grain. Maybe aroma and oil are piggybacking on each other. There's a linkage in biochemical linkage between the two. And one more thing happened was the biodiversity of microbes was higher under aerobic condition. In fact, in retrospect, we realized that the biofortification is coming from these guys. They are doing the job of sending nutrients into the grains, into the roots, because they're multiplying the root zone 100 times, mycorrhiza and all that, and non-symbiotic nitrogen fixers are there in rice. If you put water, all of them are gone, because aerobic condition and anaerobic condition are like coffee and tea, just somebody mentioned. Some people think both, of course, but they're as distinct as the two. And microorganisms clearly enhance are enhanced under aerobic condition. That's what we have realized. 3 independent studies have brought this out. And that's success story from Bangalore. And this is a success story from TNAU. My colleague Chandrababu has done great work over the years on QTL pyramiding and root studies, and trained a lot of students. And then he's got this variety called Anna 4, and traditional breeding, farmers participatory variety. Incidentally, Satish Verulkar, me, and Chandrababu, all three practice the same strategy, similar strategies. Participatory varietal selection, we dabbled with markers in the laboratory, but we kept on breeding in the field. So we got results. Then now this is his field, very severe. And he monitors water. One of the things that all three of us did commonly was using water as a trait in the selection process. We measured water. That's all there is. Per unit grain yield, how much water went in, using different strategies. And all of us worked with farmers, participatory farming. And this is one of his cross. And all of us did one more thing. We took female as a local variety. So that made a lot of difference in our outcome. And this is the variety, one of the varieties he developed. It's extensively cultivated now. MLT data. RRF is the latest one that he's coming up with. And all the thoughts, philosophy in drought resistance that I speak of has been put in this freely downloadable article called Breeding for Drought Resistance Using Whole Plant Architecture, Conventional Molecular Approaches. This is in-tech publication, freely downloadable for anybody. It's been downloaded a lot already. And now that's about the success stories. The organizers also told me to spend some time on what could be done differently to increase the number of success stories. Well, here it is. I think water equals money. A water resource near a tank or some canal, fortunately, without your effort. You can save it when you have it only. Can a farmer who is facing drought save water? No. Can a poor farmer save money or a poor interest? No. So money is equal to water if you can think of it that way. And lack of money is bad. Excess is also bad in some way. And uh, both are utility of both are based on time and space. At a particular time, a little, even 1 rupee or $1 has worth of $100, and $100 is worthless sometimes. So, and sorry, there's a mistake here. ROI, or it's not a mistake, expanded. Return on investment. A industry's success is based on return on investment that is made. An agriculture is, or a variety can be measured in water productivity. So if anybody asks me what is the single trait that is a measure of drought resistance, I would say water. Grain yield per unit of water given per day. That's the ultimate measure. And we scan the descriptors to see how much importance is being given to roots. And you'll be surprised to see, descriptors are supposed to have everything about a plant. Describe everything about a plant in a standard way, particular way. Everybody should follow that methodology. But surprisingly, sorry, misplaced slide. Um, all the descriptors of rice, wheat, sorghum, and maize were compared for vegetative characters, grain characters, stress characters, and root traits. I may be wrong. Please help me to find how many root traits are there in descriptors. We have not spent enough time to describe our germplasm accessions in a particular way that should have been done. I could find one trait in a rice descriptor and one trait in a maize descriptor. In these two, I did not find any. If I am wrong, please help me find root traits in descriptors. I missed a slide. Okay. Stability versus specific adaptability. This is a debate that is going on. In future, probably not using means as a selection process. ASERP, Indians know that. All India Coordinated Research Programs work on multi-location trials. You have trials across the country, seasons, locations, and all that. And finally, the means come up, means from one location come up, the region means come up, and finally they're analyzed. But in the whole process, local adaptability information is lost. We lose information, such a valuable piece of information. And one of the other things about ASRP is location-specific research. So there's a contradiction. You eliminate genotypes based on their mean performance, first mistake. Second mistake, you eliminate experiments based on CV. CV is something that is a measure of health of an experiment. But in a drought experiment, if one of the genotypes happens to be susceptible, or for whatever reason it doesn't come up, be it a check or an entry, the whole experiment is rejected. What is the mistake of the genotype which did well? So there should be a different thinking for drought experiments, different thinking for non-drought experiments. Unless we do this, we are not going to have more success stories in future. Location-specific adaptation not considered as mean. I told you this. Not reject based on CVs. Genetics. I think this is the future. As a professor in agriculture university, I teach students left, right, and center, all degrees, all courses related to genetics, plant breeding, and biotechnology. I feel that this is an entirely unexplored area of opportunity, but we don't teach it at all. When we deal with climate change and issues related to climate change, epigenetics is going to hit us harder than genetics. You may know all the genetics you want. Since last 2-3 days, we are hearing that post-transcriptional modifications, RNAi, microRNA, snRNA, all these micro small things are making a lot of difference, more difference than genetics itself per se. So presence of a gene need not mean anything if it doesn't express in the right time, in the right manner, when in the right proportion, whatever is required. So epigenetics needs to be reinvented, more invested on this. Selection for segregants is like giving an IQ test. You know, you for students you get entrance, you give an IQ test. So a breeder actually is giving an IQ test to plants if he is smarter than the plants. I really feel that plants are very intelligent, and the breeder has to be more intelligent than the plant. He has to have more empathy to find what the plant is doing, why it is doing, and does it suit the farmer's situation later. So for a breeder, we need empathy rather than any other equipment. Um, there is nothing much the equipment can do in a breeding plot, and IQ test is what is required. Uh, Need to identify multiple alleles at QTLs. Morning asked a question regarding this. There's one mistake that's happening across our labs, I feel. Tell me if I'm wrong, please. Uh, we have mapping populations developed by biparental process. All of us record data as 1 and 2 because there are 2 alleles in the parents until there's a magic population. Then when we put the data together, my 2 can be your 1, or my 2 and your 2 need not be the same. The size of the allele, because we don't mention that size of the alleles in our publications, most of us at least. So until we develop statistical resolution in our ANOVA to quantify the effect of every one of the multiple alleles that exist at every locus of a QTL, we are going to miss the bus. Then uncommon QTLs are as important or more important than common QTLs. I see a lot of publications come up which say that there is a lot of excitement about a lot of bars, QTL bars, multiple populations. But what is the mistake of the single bars that did not match? It was not their mistake. They were just location specific QTLs. If only we could do QTL analysis at multiple times based on not on means but on location specific data, we are going to do a lot of we'll gain a lot of information and knowledge that can be used for location specific breeding. Summary of my talk. Breeding for drought resistance has been successful in India. I'm very happy to say that. We have achieved something in a complex trait. Collectively, it's not my success. It's a success of all the Indian breeders, ASAP network, and international centers who backed us. The Rockefeller Foundation who supported us. IRI, who did a lot of things at the right time. And breeding for deep roots manifests as greater productivity under low moisture stress and well-watered conditions too. There is no crossover. Need not be a crossover effect. Graph can be like this. High yielding under both conditions. It's possible. And multiple institution networks function and deliver results. This is a proof. Rockefeller Foundation invested not only in human capital, they gave us a lot of money continuously. This is one thing that is not so happy with in our country, that is funding scenario. You get a 3-year grant and then you have to apply again. You may not succeed. All your material is gone. Then you start over again, or you lose interest. No, don't start at all. So, but Rockefeller Foundation ensured, for example, I got a continuous funding for 17 years. 17 years. And I was just so young then. They just saw something and gave me, and here I am delivering products. And whole plant architecture and functionality under stress is important. Whole plant architecture. A plant breeder is like an architect who constructs his building. As soon as you go to an architect with a desire to construct a building, first thing he'll do is soil. Analyze the soil, and the depth of the foundation is proportional to the height of the building, or there's some proportionality. But in a breeding program, do we do that? Most of the time, most of the architecture plant types that you see are only shoot plant types, not root. You can have a look at it. And drought as a trait is not as complex, and breeding for drought resistance is not very difficult when water is treated as a trait. And these are the people who, for organizations which funded us as a country to achieve the success that we have achieved. Thank you very much.
Thank you, Dr. Shashidhar, for an excellent talk.